This video is about projectile motion. It's going to be a killer video. So after this video, you will be able to solve any projectile motion problem without any suffering. So let's get started. So I'm going to start with a blank page as if it's a whiteboard. I'm going to discuss everything from the very beginning. But the symbols that I'm going to be using are the symbols used as per the IB. So the first thing is that you need to know that a projectile motion, it's a two-dimensional free fall. I'll be doing another video for the free falls, but let's talk about now the projectile motion. So, for example, one case of a projectile motion is that you have an object launched from the ground. So this is the ground, okay? And I have an object launched from the ground at a certain angle. So this is the initial velocity. In the IB, the initial velocity, it's taken as u, okay? And the angle with the horizontal at which this ball is being launched is equal to theta. Okay, so this is the initial velocity. Now, what you need to know is that this velocity needs to be resolved into two components. So this initial velocity, I need to resolve it into the x component, which is the projection on the horizontal axis. So this is the x component or the horizontal component, so ux, and you have to also resolve it into its y component. So this is the vertical component or the y component of the initial velocity. So the x component, if you want to find its value, since it's adjacent to the angle, so it's equal to the value of the initial velocity times cosine of the angle. While on the other hand, the y component of the velocity is the initial velocity times sine, because it's opposite to the angle, sine theta. So this is the first step that you need to do. The second step that you need to think about is that if there's no air resistance, of course, if there's no air resistance, then the only acceleration which is affecting the velocity is a vertically downward acceleration, this acceleration, the vertically downward acceleration, which is due to gravity. So this is the gravitational acceleration. If I'm taking up to be the positive, then this have to be the negative. Unless you're taking downward to be positive, then it will take a positive value. So this is, it's the minus 9.81 meter per second squared. So this is the value of the gravitational acceleration, and it's vertically downward. Now, the trajectory that it will be covered by this ball is going to be this. So this is the trajectory. It's going to be a perfect parabola. And why it's going to be a perfect parabola? Because there's no air resistance. So what will happen is that you need to think about this motion in each direction separately. So if you are talking about what's happening to the x component of the velocity, while look at the acceleration. This vector is not going to affect this vector by any mean, okay? So which means that the horizontal value of the initial velocity is going to remain constant through the whole journey. So this ux, which is the initial velocity, which is the horizontal initial velocity, it's going to remain constant through the whole journey. So every instant of time, if you are looking about what's Vx, which is the x component of the velocity, well, this means Vx is going to remain equal to ux in this case. So the first thing that you need to pay attention to it is that the x component, so A, will only affect the y component of velocity. Why is this? Because it's vertical, it's in the y direction, which means that it will not affect ux. So ux is going to remain constant. So at any time, the x component of the velocity is going to remain equal to ux. So there's no acceleration in the x direction, which means that in the x direction, the equation that I'm going to be using to study the motion is this one. First of all, you need to know that the initial velocity in the x direction, it's u cosine theta. And you need to know that the displacement traveled, so for the IB, S is for the displacement traveled in the x direction, simply it's equal to ux t. Why is this? Because there's no acceleration. In the x direction, a is equal to 0. So I'm going to be using the equations that has no acceleration in them. Okay, now if you look at the y direction, what's happening? While if you look at this instant of time, so of course, let's say this is after 1 second. So what will happen is that this velocity right here, it's going to decrease by this value every second. Why is this? Because a is opposite to the velocity. So in the first half of this motion, every second, the velocity in the y direction is going to decrease by 9.81. So what will happen is that Vy after some time, it's going to decrease. So this is Vy. And once it reaches the maximum height, Vy at the maximum height is going to be 0. But of course, there is a value for the horizontal component of the velocity, which is constant at each instant of time. While on the other hand, if you reach here like 1 second after it was at the highest position, then the velocity in the y component will be 9.81 to the negative direction. So now the object is going to start accelerating or speeding up in the negative direction. Okay? So what's happening to the y component of the velocity? First, every second it's decreasing by 9.81 until it reaches the maximum position where it's 0. Then it starts speeding up because the direction of the acceleration is the same as the direction of the vertical velocity. So which equations I'm going to use for the y direction in studying the y direction? In this case, I'm going to use the SUVAT equation, the SUVAT equation. So the first thing that you need to do is that you need to find the y component of the velocity, which is u sine theta. The second equation that you will be using is finding the velocity, which is the vertical velocity at any time by using this equation, at plus uy. And the third equation that you're going to use for studying the y direction of this motion is the displacement in the y direction is equal to half at squared plus u y t. Okay? So these are the equations where a is not equal to 0. In this case, a is equal to minus 9.81 meter per second squared. So this table, it's called the toolbox. And it's an extremely important table because whenever you have any question, they will give you the initial launching angle. Maybe they will give you the initial velocity. So you will be able to label all of these. All of these will be labeled. Okay, and of course, A, due to gravity, we know it as 9.81. Okay, so this table is extremely important in solving anything. And the only physical quantity that you can find in this side and take its value to this side is the time. So this is the only thing that you can find it in the y direction and substitute it in the x direction and so on. Now, what are the things that you might be asked about in a projectile motion? Maybe they will ask you, for example, what is the range of the projectile? Range is the maximum horizontal distance. So this is the range. It's the maximum horizontal distance. So usually to find the range, if you were asked for the range, all what you have to do is to put Sy equal to 0. Why is this? Because once the ball reaches the ground, this means that in the y direction, the ball has traveled a round trip. So it has went up and then down again to its position, which means that Sy is equal to 0. So the displacement in the y direction is 0. And from Sy, whenever you use this third equation and you put Sy is equal to 0, you will be able to find the time at the ground. And from the time at the ground, you can put t in Sx. So the time at the ground here, if you know what's this time, if you put it in this equation, you will be able to find the range. So this is how I find the range. Now, another thing that you might be asked about is what is the maximum height? So this is the maximum height traveled by the projectile motion. To find the maximum height, all what you have to do is to find the time at the maximum height, okay? So of course the maximum height, I need to find it from the y direction, but I don't know the time at the maximum height, so I will find it from this, from Vy. And why is this? Because we know that the y component of the velocity at the maximum position, it's equal to 0. So if you put in the equation 2, in the y direction, if you put Vy equal to 0, you will be able to find the time at the maximum height, okay? And by finding the time at the maximum height, you will be able to put it in Sy and find h, okay? Now, what else you will be asked in this? Maybe he will ask you what is the velocity at the ground. So he's asking for this velocity, for this v. What's the velocity at the ground? So first you need to find the time at the ground by using this equation, Sy equals 0. After finding the time at the ground, you need to find what's Vy at ground. Okay, so you need to put here t at the ground to find Vy at the ground. And of course, ux at the ground, it's always constant. So you have Vy at the ground from the time. You need to find ux at the ground, which is constant. And after that, you need to use this equation, which is the total velocity at the ground. It's equal to the square root of Vy squared at the ground plus ux squared, and you will find its value. And for the direction, it's equal to tan inverse of Vy over ux. So this is how I find the total velocity at the ground. And he can ask you for the velocity at any time. And that's it. So basically, these are most of the things that they ask about for a projectile motion. And the key for solving any projectile motion is this toolbox. So once you write this toolbox, everything will be easy. So all what I'm going to do now is to solve some examples. So let's look into this example. Of course, I'm going to discuss the other cases of projectile motion, like if it's launched horizontally from a cliff or if it's launched at an angle from a cliff and so on. So let's try to solve this example here. He's saying an object is launched at an angle 30 degrees with a velocity 10 meters per second, taking g as 10 meters per second squared approximately. Find the height, range, and the velocity at the ground. So let's start by drawing the toolbox, which is the most important thing. So my toolbox is going to look something like this. So there's the x direction, and there's the y direction. So you can call them the horizontal motion and the vertical motion. It doesn't matter. So the x direction, there is an initial velocity which does not change, and it's equal to u. So this x component of the velocity, ux, it's equal to u cosine theta. So if I want to substitute it here, so it's 10 cosine of 30. Okay, so this is equal to 10 cosine of 30. I'm going to, so cosine 30 is radical 3 over 2 times 10, and the value is going to be 8.66. And the y component of the initial velocity, which is this, it's uy equal to u sine theta, which means that it's 10 sine 30. Sine 30 is half, so 10 sine 30 is a 5. So 5 meters per second. So this is the first part of the toolbox. It's done. I have found the initial velocity in the y component and the x component. The second thing is that I need to find the displacement in the x direction. It's equal to ux, which is 8.66. So ux t. Okay, so I'm done from these two first equations, this and this. Now, for the other side, we have Vy equal to A, but A is in the negative direction, plus Uy, which is 5. And the displacement in the y direction, it's minus 10 over 2, so minus 5 t squared plus 5t. So this is my toolbox that I will be able to answer all of these questions. To answer the first question, finding the height. So as I told you, once the object reaches the maximum height, this means that Vy is equal to 0 at max height. Which means that if I put Vy equal to 0, then I will be able to find the time at the ground. So this means that the time at the ground is equal to minus 5 over 10, which is 0.5 seconds. So this is the time at ground. Now, if I put the time at the ground in the SY, so to find the height, I need to take the SY equation, which is the minus 5t squared, but instead of t squared, I need to put the time at the maximum height, plus 5 times 0.5, which is the time at the maximum height. And I need to do it using a calculator. So just 1 second. So the answer is going to be 2.375 meters. So this is the maximum height. Now, if you were asked to find the range, then if there is no air resistance, then this means that the time at the ground this time is double the time at maximum height. Okay, so it's going to be 1 second. But let's say that I was not asked for the height. Maybe I was directly asked for the range. So I need to find the time at the ground. So at the ground, Sy is equal to 0 at the ground because it's a round trip. So if I put Sy equal to 0, then this equation, which is Sy equal minus 5t squared plus 5t, I can take t as a common. So this means that this equation has two solutions. The time at the ground has two solutions at t equals 0, which is at the beginning of the time, and at t equal to minus 5 over minus 5, which is 1 second. So this is the time once it reaches the ground again. Now I can find the range by Sx. So to find the range, so the range is Sx, but taking t as 1, which means that the range is equal to 8.66 meters. So this is the range of my motion. Now, if I want to find the velocity at the moment it hit the ground, then in this case, I need to find, I have the velocity at the ground, it's 1 second. So the third thing, I need to find ux, the x component of the velocity at the ground. It's going to remain constant. And I need to find Vy at the ground. So I need to substitute the 1 second in the Vy. So this is equal to 8.66, it's constant. But Vy is going to take the value of minus 10 plus 5, which is minus 5 meter per second. And the minus sign makes sense because Vy now is downward. So to find the total velocity, it's a square root of Vy squared plus ux squared, because I'm using the Pythagoras theorem, because I need to find this, which is the resultant vector. So it's equal to square root of minus 5 squared plus 8.66 squared. So let me do it. By the way, it's going to be equal to the initial one, but in the negative, of course. So let me just do it. So power 2 plus 5 power 2 under the radical. So look at the answer. It's 9.99. Actually, it's 10 approximately meter per second. So I need to say something. Whenever there's no air resistance, the motion is going to be symmetrical. So I started with 10. I'll end up with 10, but in the negative direction. Now to find the angle with the horizontal, I'm finding this angle here. Okay, so the angle is going to be equal to tan inverse of the y component over the x component. Okay, because it's the opposite over the adjacent. So it's equal to tan inverse of minus 5 over 8.66. It's going to be the same as 30, but let me do it again. So it's minus 5 divided by So the answer is 30. And it's going to be minus 30 because it's under the horizontal, so minus 30 degrees. So this is how I'm finding the value and the direction of the velocity using the toolbox. Now, if you were given an example of a projectile motion which in such a way that it was launched from a cliff, okay, but it's launched horizontally. So basically this is the easiest projectile motion. Let's say u initially, it's equal to 10 meters per second. And of course, there's the acceleration downward. Let's take it as 10 meters per second squared. I'm going to take downward as positive because all the motion is going to be downward. So this is the motion of the projectile motion. Let's say that the cliff is 100 meter height. So this is the height of the cliff. And he's asking for, so this is example 2. He's asking for part A, find the range, so this range, okay, find the range. B, find velocity at ground. So at the moment it hit the ground. So in this case, of course, I need to start with the toolbox. Okay, so this is the x direction. This is the y direction. The x direction, ux is equal to u because there's no x component. Look, the x direction is the same as u. So there's no y component here. So ux is 10 meters per second, but uy is 0 because the projection on the y-axis of this vector here, it's going to be 0 because the angle is 0. So sine of 0 is 0. Now, the x component of the displacement, it's 10t, and Vy is going to be equal to 10t plus 0. Let me fix this a bit. So I'm making this video quickly because I was asked a lot about projectile motions. And the y component of the displacement is half at squared, so 5t squared plus 0. So can you see the toolbox? It's extremely easy toolbox to use. To find the range, part A, at the ground, here at the ground, Sy, it's not equal to 0 now. Sy, it's equal to 100, okay? Because I'm going downward, a vertical, a displacement of 100. So at ground, Sy is 100. And I'm taking it as plus 100 because I'm taking downward as positive. Which means that if you put 100 in this equation, you will have this relationship. So now I can find what's t. So it's 100 over 5, okay? Which means that t is plus or minus radical 20. Of course, the negative is going to be neglected because there's no negative time. I'm going to take the positive. So square root of 20 is 4.47. So at the ground, the t is equal to 4.47 seconds. So after 4.47, it reaches the ground. Now I can find the range. So Sx, which is from which I'm going to find the range, it's 10 times 4.47, which means that the range is 44.7 meters. Now to find the velocity at the ground, I need to find ux. At the ground, it's 10 meters per second because it's constant, ux. So at every moment, the horizontal component of the velocity is constant. But the vertical velocity, at the beginning it was 0, and then it's going to speed up in the positive direction, the same way as the free fall when the object is dropped. So now Vy at the ground is equal to 10 times the time at the ground, which is equal to 44.7 meters per second. And in the same way, you will find V. So V is square root of ux squared plus Vy squared, and you find the value. Now, this is the magnitude, as if he's asking for the speed. For the direction, of course, it's tan inverse of Vy over ux. So I'm doing it kind of quickly so that I can discuss the third type of projectile motion. So the third type of the projectile motion is if the object is thrown from the cliff, but in such a way that it's thrown at an angle. So this is the most complicated one, but it's not, okay? So if it's launched like this at an angle, let's say this is 30 and this is 10 meters per second. This is the ground. This is the acceleration due to gravity. I'm taking it as 10 meters per second squared, but I need to take it as minus 10 because now the motion is an upward and downward motion. So you have to take one direction to be positive. Let's say that the cliff is 100 meters high. And he's asking for exactly the same thing, the range and the velocity at the ground, okay? But the toolbox here is going to be a bit different because there is initial vertical velocity. So this is the x direction, this is the y. Ux is 10 cosine 30, okay? So 10 cosine 30 is 8.66. And Sx is 8.66t. Uy, the y component of the velocity, is 10 sine 30. So it's 5 meters per second. This is the Uy. Vy is A, which is minus 10t plus 5. So I'm taking A as minus 10 because it's downward. And Sy, it's half at squared, so minus 5t squared plus 5t. So I need to tell you something, that here the toolbox, it looks very similar to the previous one, but the way of solving is going to be different. So here, if you want to find the time at the ground, what's the time here? You can take Sy as 0. So at the ground, Sy, okay, which is the y component of the displacement, is equal to minus 100 meters because the displacement is downward and it's 100. Okay, so you will find the time at the ground to find the range. Okay, you will find the time at the ground by putting minus 100 meters in this equation. So it's going to be a two equation. It's going to be an equation that you need to use, a quadratic equation. You need to use your calculator here. So minus 5t squared plus 5t plus 100. Okay, you can divide by 5 and you will have minus t squared plus t plus 20. Okay, and you can solve it. So the answer here is going to be t equal minus 4, one solution, second, which is rejected because no negative time. And the other solution is a t equal 5, which is the accepted solution. So after 5 seconds, the object will reach the ground. From this, I can put the time in this equation to find the range, okay? And then I can use this time to put it in this equation to find Vy at the ground. Having Vy at the ground and Ux at the ground, you will be able to find V, which is the value of the speed, and the direction by using theta equal to tan inverse of Vy over Ux. So I hope you understood the projectile motion in this very quick video. Basically, this video was done without any preparation. And if you have any question, please tell me. So the key for solving any projectile motion is this table. The second thing is that to know how to substitute for every physical quantity that he's asking for. So that's it. And I'm going to stop here.